हेलो एवरीवन, कैसे हो आप लोग। आई होप एवरीबडी इज डूइंग वेरी वेल गाइस एंड वेलकम टू माय न्यू यूट्यूब चैनल Mudgal education where I am providing you the content for your upcoming gate examination, also going to help you in a different government exams. So this is my initiative for the guys who cannot afford the costly education and the costly coachings. So I'm here to providing you the help as much as I can. So you can watch this video and first of all learn the topic on the diode circuits. Now if you are new to this channel, you can watch my previous videos that I have already uploaded on a network theory and a signaling system. So I'm uploading a videos on an important topic so that sometimes these important topics students skip or they don't get the complete knowledge on these topics. That's why I'm uploading the videos on very specific topics. Now before starting a topic, let me tell you that I have already my Telegram channel. You can join my Telegram channel by giving that link in a description of this video. Also guys, the app has been launched that was on which I was working for the few days. So the link of the app is also given in a description section. You can download the app, join my paid courses where we can practice and we can learn for the upcoming gate and different examinations. So let me introduce myself. My name is Ishaan Mudgal. I have a 7+ year of teaching experience. I'm Tech Gold Medalist from NIT Allahabad, 8 times GATE qualified, and these are my area of expertise. Now guys, before going further, let me give you one more information that if you join my Telegram channel, you can post your doubts there. If you have any particular doubt related to technical or non-technical subjects, you can also post there. Now let me just show you how you can download the app. As you can see, you can go to a Play Store, you can search Mudgal Educations, and once you search the Mudgal Education, you can get this app as you can see here, this particular app, and then you just need to install it. After installing it, what you can do, you can go through the app. Right now the app is in beta section. You can also get the link of my YouTube and a Telegram group link from the app also. And the course I'm going to launch from the 29th April. So particularly I'm going to launch 3 courses. The major course is the Arambh batch, which I'm going to launch for the GATE 2025 for electrical and EC both. And also in this particular batch, I'm going to start my network theory and signal system classes. On this particular app, you can also send me the message directly and we can discuss your queries and everything. And here you can see this particular screenshot of the app. Let me show you. Right now these 3 courses I am going to launch together. The RM batch is for both electrical and EC. Then on this RM batch we are going to start a signal system and network theory classes. Right now the prices of these courses are at a minimum level. You can either purchase the subject wise course or the complete gate course. Okay, so we can start. Okay, so enough promotion, now we can start here. So today's class is based on a diode circuit. So before starting a class, let me quickly revise you the concept that we are going to use in today's question. Also these concepts are very much helpful because you can expect at least 3 marks question based on this on your upcoming gate exam. Now if you talk about diode, the simple, what is diode? A simple diode is a switch, nothing else. Diode is an electronic device that act like a switch. Just like a switch, diode can be on. Just like a switch, diode can be on, and just like a switch, diode can be off. Now when you talk about the ideal diode, this is the ideal diode. To turn on the ideal diode, what you need to do, as you know, diode has 2 terminals, anode and cathode. Just anode voltage must be greater than the cathode voltage. When the anode voltage is greater than cathode voltage, then diode is actually forward biased and it will be turned on. When the anode voltage is less than the cathode voltage, diode will be reverse biased and it will be turned off. Now if I talk about a practical diode, for every practical diode there will be a cut-in voltage. Now what is actually a cut-in voltage? Cut-in voltage is due to the electrical field induced inside a PN junction due to the depletion layer generated. Now to overcome that electrical field, so that electrons can jump from one side to another side, you have to apply the external voltage. That voltage must be greater than the voltage due to that internal field. Okay, so the internal field is known as a cut-in voltage. So basically, if anode minus cathode voltage is more than the cut-in voltage V gamma, then the diode is forward biased and it can be replaced by a voltage source having the magnitude V gamma. Okay, this is known as a constant voltage model. This is known as the constant voltage model. Apart from that, we have another model which is known as the piecewise linear model. In a piecewise linear model, there will be a forward resistance which is given in a question. So this is the piecewise linear model. This is the piecewise linear model. Okay, now what is the major difference between these two models? The major difference here is that the diode voltage, if you talk about the diode voltage is constant voltage model, it is V gamma. But if you talk about a diode voltage in piecewise linear model, let's suppose diode current is ID, then in this case diode voltage is IDRF plus V gamma. Now the main point you need to understand here, in a constant voltage model, diode voltage is constant, but in case of a piecewise linear model, it is dependent on the diode current. Now in a reverse bias, there will be only one case. In reverse bias, simply the diode is going to be turned off. Diode is going to be turned off. Now before going further, if you want more about a diode, how it's working, what's the junction behavior there, how you can create a different kinds of model of a diode, what you can do, you can comment in this, but you can do the comment on our comment section and tell me if you want the video on that particular topic also. Right now we are going to solve the questions, but before that I'm just providing you a simple basics here. But you want the complete video on this basic, you can provide a comment on my comment section. Okay, so this we know about a particular ideal diode and a practical diode. Now during the question solving, or when you practice the question, one thing you need to understand, in your exam you are going to get the multiple diode question. A single diode question is much easier to solve. You can easily identify whether the diode is on or off depending on a voltage source and all. But when you have a multiple diode circuits, it's not easy to identify it. You have to use two methods to identify whether the diodes are on or off. What are two methods? The first one is a short circuit method. What is the short circuit method? Let me tell you. First, you have to assume that diode is on. You have to assume a diode is on. Now if a diode is on, then it will be replaced. If a diode is on, it will be replaced by a short circuit in case of an ideal case, and in case of practical case, it will be replaced by a voltage source in case of a practical case. Okay, so we have to assume that diode is on. Okay, now after you have assumed it, what you have to do, you have to calculate the current passed through it. Now third point, if diode current is more than 0, then assumption satisfy. If diode current is more than 0, then assumption satisfy. But if diode current is less than 0, it means your assumption is wrong. You have to take the diode in an opposite manner. Okay, for example, if you are using a short circuit method and you calculated that diode current is less than 0, it means the particular diode is off. Okay, so this is important. You have to take the assumption first, and then you have to decide whether diode is on or off. After that, whatever they are asking in a question, you can solve it. But first you have to confirm yourself that what is the state of a diode, whether it is on or off. Next we have an open circuit method. What is the open circuit method? Here you have to assume that diode is off. Obviously, whether it is an ideal diode or a practical diode, when a diode is off, you have to take it as a open circuit. Now understand here, when this is an anode voltage, it is always taking as a positive, cathode is always taking as a negative, and this is a diode voltage. You need to understand one point here. that diode voltage is always anode minus cathode voltage. Diode voltage is always anode minus cathode voltage. Now second point is calculate diode voltage. You have to calculate a diode voltage. Now third point is important. If diode voltage is less than 0 or diode voltage is less than V gamma in case of a practical diode, then we can say our assumption is right. That assumption is right that diode is actually in a off state. Assumption is right. Otherwise assumption is wrong. And if the assumption is wrong, then obviously the diode will be on. Okay, so these two methods are very important to identify. Whatever the circuit is given, for example, rectifier is given, clipper is given, and you can say the Zener diode circuit, voltage regulator circuit, whatever the circuit is given, if you understand these two methods, you need not to identify the circuit based on its function, whether it's a clipper circuit or a rectifier circuit. You can solve the question easily and much easier manner. Okay, understand this point. Now moving further, let me tell you the 2 points. What is the transfer characteristic? What is a transfer characteristic? Many times question has been asked you to draw the transfer characteristic. Now transfer characteristic nothing but it is a graph between output voltage and input voltage. It is a graph between output versus input voltage. That is actually a transfer characteristic. So when you have to draw a transfer characteristic, you have to find out a relation between output and input voltage, and then from that relation you can draw the particular graph or the characteristic. Okay, understand this point. So this is the basic right now that we have taken. If you want a complete video on this basic, you can put your particular desire on my comment section, and we will bring that particular video also. Now let's try to solve the questions further, because basically this is our question class. So let's try to solve the question further. So this is the first question on your screen. So I will advise everybody to pause the video and try it by yourself first, and then we will solve it together. So the question is, the IV characteristic of a diode in the circuit given below are this. So what they have given? They have given the relation between the current and voltage across a diode. Now they are asking what will be the current in the circuit. Now understand this carefully. They have said that this is a current and voltage relation when the particular diode is on. Obviously V greater than 0.7, and when the diode is off, then obviously it is a 0 ampere. Okay, now when they say V is greater than equal to 0.7, the diode is on. Now one point you need to understand here, that this diode is actually a forward biased. This diode is actually forward biased. Why? Because the 10 volt is connected across the anode. So since the diode is forward biased, I can take the diode on. There is no need to take assumption. I can take the diode on, and once the diode is on, the voltage across it is actually V. Once the diode is on, the voltage across it is actually V, and this is 10 volt, and this is the current I. Now from this circuit, can I find out a current? What is the formula of current? Higher voltage minus lower voltage divided by resistance. I am taking the resistance as 1000. Why? Because in the question also they have given in ampere. So right now the voltage is 10 minus V upon 1000. Apart from that, there is a current which is flowing in the same circuit, is given by V minus 0.7500. So can I say 10 minus V by 1000 is actually equal to V minus 0.7 by 500, because both the currents are actually same. So after solving this, what we are getting 1.4, then if we are getting 11. V is equal to 11.4 by 3. You can check the calculation also. 3.8 volts. Okay, you can check the calculation also. Once you go into this particular video, you can check the calculation. If there is any calculation mistake, you can provide that particular mistake in a comment section also. So here you can see simple question, because here you can see the current is also given, and also since the diode is forward biased, the particular flow of current will be from 10 volt towards the diode, and we can calculate the current equation also, right? Next question. Assuming that diodes are ideal in the figure, the current in diode D1 is. So they are asking what will be the current in diode D1. Okay, now this is the question based on multi-diodes. This is the question based on multi-diodes. Now when you have a question based on multi-diodes, you need to make sure that you have to use the open circuit and a short circuit test, either of these tests, or you can use both tests together in a same circuit also. But before using that, you have to take the first assumption, that is important. And when you are taking a first assumption, you can use the basic common sense. It may happen that the first assumption may be wrong, the first assumption may be right, but if you use the common sense there, then there is a high chance the first assumption will be correct, and you need not to take further assumptions in a question. For example, see this question. I can see that diode D1, the anode is somewhere connected to some part of 5 volt and the cathode is actually grounded. If I take this node as a ground. For a D2, I can say some part is connected to 5 volt and the cathode part is connected to 8 volt. So can I take first assumption here? Can I take first assumption here that D1 is on and D2 is off? Why I am taking this assumption? Because across D1 I can observe that anode voltage is greater than cathode voltage. Across D2, cathode voltage is greater than anode voltage. So obviously I can take this assumption. If I am taking this assumption, the circuit will become like this because it's an ideal diode. So short circuit, and here it will be open circuit like this. Now now we have to check whether our assumption is correct or not. Don't solve the circuit without checking the condition or without checking your assumption. Okay, so let's suppose I need to find out ID because I have taken the D1 to be on. What is ID? ID is 5/1, which is greater than 0. Okay, now which is greater than 0, I can say assumption for D1 is correct. I can say assumption for D1 is correct. Now let's check for D2. D2 is a voltage across it. D2 is a voltage across this particular open circuit. So what I can do, I can apply the KVL. To calculate the D2, I can apply the KVL. Where I should apply KVL? I will say I will apply the KVL in this here. Okay. So we have a plus VD, we have a plus 8, then we have a 0. Diode voltage comes out to be minus 8 volt. Also understand one point, there is no current across 1 kilo ohm. That's why the voltage is 0. So here also I can say, since the diode voltage is less than 0, the simple point is our assumption for D2 is also correct. So if we use the common sense, there is a high chance that our assumption will be correct at first time. If it is not correct at first time, we have to take a different assumption again. So simply, if our assumption is correct, this is the main circuit that will actually behaving. This is the main form or the state of a circuit in which the particular circuit is actually behaving. Now they are asking, what is the current in diode D1? That we have already calculated. It is 5/1. I can say the milliampere because resistance is kilo ohm. So the simple answer is 5 milliampere. So the simple answer is 5 milliampere. Understood this point? Yes or no? Okay, simple question. Just you need to make sure how to take assumption and how to check the assumptions. This is important. You have to check your assumption also. Let's solve the next question. In the figure, assume that the forward voltage drop of a PN junction D1 and a Schottky diode, it's a Schottky diode written, at D2 are 0.7, 0.3 volt respectively. If on denotes the conducting state of a diode and off denotes the non-conducting state of a diode, then what will be the state of a circuit? Then in the circuit, the question is actually half. Then in the circuit, what is the state of a diode? What is the state of diodes? We basically identify whether the diodes are on or off. Now you can see the Schottky diode is written here. If a Schottky diode is written, is given in a circuit, there is no need to worry about it. In a circuit, it will behave exactly like your practical diode. Okay, what is Schottky diode? That's a different concept, but actually right now you don't require the meaning of a Schottky diode. You just need to understand it behave exactly like your practical diode. Okay, so here you can see we have two practical diodes here, D1 and D2. Now if I use my common sense here, I can say if I'm taking this as a particular ground, then I can observe anode is connected some part of 10 volt and the anode of D2 is also connected to some part of 10 volt. So using a common sense, I can say ki okay, D1 and D2 can be on. So I have to take the assumption here. So I'm going to take assumption that D1 and D2 are actually on. Now if I'm taking D1 and D2 are actually on, the circuit will be like this. The D1 is what? 0.7 and 0.3. Across D1, the voltage source is 0.7 and the cut-in voltage of Schottky diode is 0.3. It is 0.3, it is 0.7, and here we have 10 volt. Here we have 10 volt, 1 kilo ohm and 20 kilo ohm. Now I need to find out what will be the current flows through both diodes. Let's suppose this is ID1. Let's suppose this is ID2. Now understand here. Very good question. Very good question. Now understand here very carefully. If I take this node as a ground node, then the voltage at this node becomes 0.7. So can I find out what is ID2? I can say ID2 is actually equal to 0.7 minus 0.3 divided by 20 kilo ohm. So it comes out to be 0.4 divided by 20 milliampere, and how much I am getting? 1 by 50. I will say, so 1 by 50, or I will say 2 by 100. Obviously 1 by 50. Okay, 0.02 milliampere. This is ID2. Now let's calculate the current I which is flowing here. So I can say what is I? I is actually equal to 10 minus 0.7 divided by 1 kilo ohm. So it comes out to be 9.3 milliampere. It comes out to be 9.3 milliampere. Okay, understand? I hope there is no problem in a calculation. Okay, if you find out any problem, bacha, you can tell me directly in my comment section. Okay, any doubt here? Now try to solve this question further. Okay, what will happen again? Think about it. What will happen again? So we have a ID2 as well as we have a ID1. Now can you find out the ID1 here using a KCL? Now if I apply the KCL here, what is the ID1? It will be equal to I minus ID2. So it comes out to be 9.3 minus 0.02. It comes out to be 9.28 milliampere. It comes out to be 9.28 milliampere. Okay, understood? Now wait a sec, let me just check the question again. If I have done some mistake here, let me just check the question again, whether the question is right or wrong. Wait a sec, just wait a sec. Okay, so what we have here, let me check. We have a 1 kilo ohm. We have there's one mistake here, guys. There's one mistake here in the question. That's why because this question has been asked in your examination, so I know there should be one mistake here. So there is a one mistake here, guys, that actually this is not 20 kilo ohm. In exam when this question was asked, it was 20 ohms. But okay, I'm not going to change it. You can understand here the particular ID2 and ID1. Let's solve this, and then I will solve the question that has been asked in your exam. So here you can see both ID1 and ID2 are greater than 0. It means our assumption is true. And if our assumption is true, I can say directly that D1 and D2 are on. So this is the answer for this question. That D1 and D2 are on. Understood? Any doubt here? Now let me tell you the question that is actually asked in your examination. So wait a sec, let me add one page here. Okay, now see very carefully. In the exam, the question was, it was exactly like the previous one. But the resistance was actually the resistance was actually 20 ohms. Yes, this was 20 ohms. The resistance actually was 20 ohms. Let me write down properly. Okay, so the resistor here was 20 ohm and it was 1 kilo ohm, it was 1 kilo ohm and it is 10 volt. Okay, now let's solve this question again. Again everything is same. Now everything is same. I am going to assume that both diodes D1 and D2 are on. If both diodes D1 and D2 are on, I can replace this diode with a voltage source. So let's replace this diode with a voltage source and redraw the network. Replace this diode with a voltage source and then just we need to redraw the network. Wait a sec, just problem in my pen. Okay. So we have 0.7, we have here the 0.3 volt. Okay, now let's take this as a ground and this is actually ID2, this is actually ID1, this is actually I. This voltage becomes 0.7. Now what is ID2? ID2, it is 0.7 minus 0.3 divided by 20. It comes out to be 0.4 divided by 20 ampere. Now I want to convert this into a milliampere, or let's not convert it, I will say to 0.02 ampere. It comes out to be 0.02 ampere. Simple. Or you can convert it into milliampere, so it comes out to be 20 milliampere. Right? Simple. Now here, what is the I? Total I. Total I is 10 minus 0.7 divided by, I will say, the 1 kilo ohm. So it will be a 9.3 milliampere. Now what is the ID1? According to a sign, I will say ID1 is I minus ID2. What is I? I is actually 9.3 minus 20. So it comes out to be a negative. Now ID1 is less than 0. But according to our assumption, ID1 must be more than 0. It means our assumption is wrong. What is actually happened? Since the ID1 is less than 0, that diode D1 is off. And you can see ID2 is greater than 0. So I will say diode D2 is on. Diode D1 is off and diode D2 is on, and that will be the right answer that has been asked in I will say the EC examination. This question has been asked in EC examination. Okay, so you can see one point here. You can see clearly one point. Because of a change of resistance, the same circuit. Because of the change of resistance in the same circuit, I can note this point clearly that we have a different state of a diode. Understood? Any doubt here? Okay. Wait a sec. Okay, fine. Understood? Any doubt here? Now let's solve the next question. Okay, so we have a next question on the screen. See very carefully and again pause the video and try to solve this question by yourself. Okay, so let's solve it. So we have a question. The equivalent circuit of a diode during the forward biased and reverse biased condition are shown in a figure. If such a diode is used in clipper circuit of the figure given below, what will be the output voltage V0? First of all, they have given you the clipper circuit. No need to worry about it. What is clipper? What is clamper? You just need to learn the basics. Once you learn the basics of a diode without understanding the concept of clipper, you can solve the question easily. But just for your comfort, let me tell you, clipper is a circuit which actually clip out some part of an input waveform, or I can say the remove some part of an input waveform, and that is a clipper. For example, in a half wave rectifier, if you talk about the half wave rectifier, the input is like this. This is the input of a half wave rectifier. Now what is the output of a half wave rectifier? Like this. So some part of input waveform has been clipped out. So that's why half wave rectifier is also a clipper. But we will bring some videos based on clipper and clamper separately. Let's solve this question first. So they're asking the equivalent circuit of a diode is given. We have to draw the output voltage curve, and we are actually given these 4 options to draw it. Okay, so let's solve the question one by one. So we have given this circuit. Let me draw the circuit first. So we have this particular circuit, and we have 10 kilo ohm. Okay, we have 10 kilo ohm. Fine. This is 10 kilo ohm, this is 5 volt, this is actually a AC source of 10 sine omega t, and here you can see this is actually missing in the question, it is 0.7. So it is 10 sine omega t, and we have a practical diode having cutoff voltage of 0.7. Now we need to solve this circuit. Now we need to find out the output voltage curve with respect to time. Now how can we do that? Simple. Short circuit and open circuit test we have to follow. Now here, see very carefully. Now see here, see very carefully. I am going to do the open circuit test. I am going to do the open circuit test. In an open circuit test, what you have to do? You have to open circuit this particular diode and find out the diode voltage across it. And find out a diode voltage across it, plus minus V naught, it is 10 kilo ohm. I will say this is the input voltage. Right now I don't require the output voltage. Right now I don't require the output voltage. Okay, so this is a diode voltage. Actually this is not a V naught, my fault. This is not a V naught. Let me erase this thing. This is actually a diode voltage. So this is actually a diode voltage, it is 0.7. Okay, let's find out a diode voltage here. Now here you can see this is 10 kilo ohm, this is 10 kilo ohm, and this is the input voltage. The current is going to flow in outer loop. So can I say the voltage is actually divided equally across these two resistors? So this is plus minus V in by 2, and it is also plus minus V in by 2. Now I can apply the KVL here. So if I apply the KVL here, I will say we have a minus input voltage plus V in by 2 plus diode voltage plus 0.7 equal to 0. From here I am getting not 0.7. Okay, again my fault. What I am doing today. It's not my fault. It's not a 0.7 bacha. It's actually a 5 volt. It's actually a 5 volt. It is not a 0.7. Okay. So we have a 5 volt here. Okay, so what is a diode voltage? Diode voltage actually equal to minus 2V in. So it is V in by 2 minus 5. Okay, let me just check the calculation here. So minus 2V in, it comes out to be minus, correct. So diode voltage comes out to be V in by 2 minus 5. Now understand here, this is the condition we are getting. We are not getting the actual value of diode voltage. We are getting a diode voltage in terms of an input voltage. When we get a diode voltage in terms of an input voltage, it means there will be some conditions that is going to occur there. There will be some conditions there. What is the condition? How to find out? See very carefully. I will say if diode voltage is greater than 0.7. If diode voltage is greater than 0.7, I will say diode is on. Now what is the condition when diode voltage is greater than 0.7? It means V in by 2 minus 5 is greater than 0.7, or I will say V in is greater than 2 7 14, 11.4 volts. If input voltage is greater than 11.4 volt, I can say that diode is actually diode is on. But the problem is input voltage is 10 sine omega t as given in question. So the maximum voltage of input can only be 10. Maximum voltage of input can only be 10 volt. It can never be more than a 10 volt. So I can say that diode can never on. In this particular question, diode can never on since V in max is less than 11.4 volt. Simple doubt. Now it means diode is off, and the condition is V in must be less than 11.4. It means that diode is off. Diode is off, and I can say in this circuit diode is always off. I can say in this circuit diode is always off. Now since the diode is always off, you can get exactly the circuit like this. You are going to get exactly the circuit like this, है ना? Understanding the concept ना? We find out a diode voltage, and after taking an open circuit test, and we find out that diode voltage is not an actual value. It comes out in terms of an input voltage. It means I can get a condition from here, there, and identify whether diode is on or off. Okay, at which particular point. Since the condition comes out that diode is on when the input is more than 11.4 volt, it means diode can never turn on because the maximum voltage the input has is only 10 volt. It means diode is always off. Since the diode is always off, it's going to follow this particular circuit, and in this circuit you can check output voltage is actually input voltage by 2. In this circuit you can check the output voltage is actually input voltage by 2. Okay, simple. So if this is the curve of an input voltage, I have an input voltage 10 sine omega t like this. So this is minus 10, this is 10. Then what is the output voltage? It is clearly mentioned here now that output voltage is input voltage by 2, nothing else. Output voltage is input voltage by 2, nothing else. So 5 and minus 5. Simple. So I will say option A is the right answer. I will say option A is the right answer. B, C, D are wrong. B, C, D are wrong. Okay. Understand this question? I hope. Okay. Simple. If you have any doubt, you can join my Telegram channel and ask your doubts there clearly. Okay. Now let's do the next question. Two silicon diode with a forward voltage drop of 0.7 are used in a circuit in the figure. The range of input voltage Vi for which the output voltage V0 is equal to Vi. Okay, now understand this question. This question is again from a clipper, but I am not going to tell you how you can use the clipper concept. Once you understand the open circuit and short circuit test, you can solve this question easily. Now they are saying what will be the range of input voltage for which output is equal to input. If you see the circuit clearly, to make output voltage equal to input voltage, both the diodes should be off. Both the diodes should be off, है ना? If both, I will say if D1 and D2 are off, I will say if D1 and D2 are off, I can draw the circuit like this. If D1 and D2 are off, I can draw the circuit like this, and once I draw the circuit like this, you can say output voltage is equal to input voltage. Simple. But we need to find out a range of input voltage for this to be happen. For that we have to use the conditions. How? See very carefully. It is minus 1 volt, it is 2 volt. Now this is plus minus VD1. Why? Because anode is always kept at positive terminal, cathode is negative. Here the anode is here, cathode is here. So it is VD2. It is a VD2. Okay. Now again I need to find out VD1 here, and I need to find out the VD2 here. Okay, simple concept. You're understanding here. You need to find out VD1, you need to find out VD2. Now for this, here you can see when both the diodes are off, you can see no current is going to pass through it. So it means the voltage at this terminal is actually the input voltage. This is actually a input voltage. Now can you say what is the voltage across VD1? I will say, or you can apply the KVL also, nothing more than minus input voltage minus VD1 minus 1. You can apply the KVL also, so it comes out to be 0. This is actually KVL. So diode voltage comes out to be minus Vi minus 1. Simple. Diode voltage comes out to be minus Vi minus 1. Okay, any doubt here? Similarly, what you can do, diode voltage V2 and positive terminal connect to Vi, negative terminal connect to 2 volt. You can also say VD2 is actually equal to Vi minus 2. Now these two diodes must be off, then only output voltage is equal to input voltage. It means for VD1 to be off, I will say the VD1 must be less than 0.7 because we are talking about a practical diode. So minus Vi minus 1 should be less than 0.7. So I will say input voltage should be more than 1.7. So if a input voltage is more than 1.7, I can say diode is off, VD1 is off. Similarly here, let me check the calculation. For this, the VD2 should be less than 0.7. I will say Vi minus 2 should be less than 0.7. Vi should be less than 2.7. Now we have to find out the common area here. We have to find out the common region here. So can I say the common region Vi is between 2.7 and 1.7. So if the input voltage, I will say if the input voltage is between 2.7 and 1.7, then I can say the particular diode is both diodes actually. both diodes are actually off. And since both diodes are actually off, we can say it clearly that output voltage is equal to input voltage. Output voltage is equal to input voltage. Understand this concept? Yes or no? Simple. See, we have solved two questions of clipper without understanding the complete concept of clipper. Okay, why? Because of the particular powerful method of open circuit and short circuit test. Once you understand this powerful method of open circuit and short circuit test, you can solve many questions of diodes without going through the whole concept. Okay, let me give you one question for your homework. So this particular question is your homework question, and I will advise everybody, guys, try to solve the question. Give the answer in the comment section. I can note that most of you are not trying to solve the question. Okay, this is wrong. Try to solve the question. Also this question and this question, I will bring one more session on the diode circuits and going to solve these two questions on that video. Okay, so try to solve both of these two questions. Now before ending a session, I will again advise you, join my Telegram channel, ask your doubts there. Also you can download our app. The classes is going to start from 29th April on the app, so don't forget to download the class. We are going to understand everything about a gate examination, and we will do our practice at the highest level. Okay, so bye guys, take care. See you in the next video on the same topic, where I will bring the more and more questions on a different kind of diode circuits.